T-minus 15 seconds.
Stop and go.
13 seconds. Green board. 10, 9,
8, 7, 6, 5, 4, 3, 2, 1. We have liftoff. Liftoff of the last United Launch Alliance Delta II rocket carrying GPS 2R21 for the United States Air Force.
Closer and closer to the speed of light, your time appears to slow down to an observer that's just sort of watching you go by. That's amazing.
When Clifford Johnson bikes around the track, he needs to be going about 56 million times faster than his current 12 miles per hour to get close to light speed. But suppose he could.
Imagine I were riding my bike close to the speed of light. Never mind whether that's possible or not. Just imagine that this was happening. My clock's running slow compared to the cameraman on the ground who's filming me. If I do that for a while, I'm going to age much more slowly than the cameraman who's on the ground. So that when I come back from the trip and come back and talk to the cameraman, he's actually much older than when I left him.
If this sounds like magic instead of science, there is proof in something that many of us experience every day.
A great example of Einstein's special theory of relativity and the fact that clocks that are moving relative to you run more slowly than your own clock, which is at rest, is the GPS system.
The global positioning system lets us drive our cars without getting lost.
Turn right.
GPS begins with a network of 24 satellites orbiting the Earth 12,500 miles above the surface. At any one time, the device in your car receives signals from at least 4 satellites and compares their light speed travel times to calculate an accurate location on the ground.
Drive 500 feet, then turn right.
The whole thing depends on super accurate clocks. And when the engineers designed the system, they knew the satellites would be orbiting at nearly 7,000 miles an hour. The speed is enough to slow down their clocks by a tiny fraction of a second. The engineers have factored all the relativistic time differences into the system, which gives it impressive precision.
If the clocks in the satellites are running at a different rate than the clocks down here on Earth, and you don't take that into account, you will get the wrong answer for where your car is.
Drive 0.1 miles to destination on left.
The distortion of time is only one of the strange results of travel.
After you go, I can catch up on my reading. After you go, I have a lot more time for sleeping. And when you're gone, looks like things are gonna be a lot easier. Life will be a breeze, you know. I really should be glad, but I'm bluer than blue, sadder than sad. You're the only light this empty room has ever had. Life without you is gonna be bluer than blue. After you go, I have a lot more room in my closet. After you go, I'll stay out all night long if I feel like it. And when you're gone, I can run through the house screaming, and no one will ever hear me. I really should be glad, but I'm bluer than blue, sadder than sad. You're the only light this empty room has ever had. Life without you is gonna be I can start my whole life over. Change the numbers on my telephone, but tonight's will sure be colder. And I'm bluer than blue, sadder than sad. You're the only light this empty room has ever had. Life without you is gonna be bluer than blue. Bluer than blue. Bluer than blue.
9, 8, 7, 6, 5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on a mission to build, resupply, and to do research on the International Space Station.